All right, everybody, Math 9, we are on to some indices. Cool story, I've never, ever heard the word indices before becoming an international teacher. We just always called them exponents. So this is a new word for me, within the last 5 years. So I might use it interchangeably. Exponents, indices, same exact thing. Index notation, we're going to talk about what an index is, the laws. These are really important. People get them really confused, and if you just follow the rules, so as you're doing these, have these rules out in front of you and always look for how you can make it get the right answer, and then pretty soon these just become basic to you. We're going to do some equations when we get back from October break, scientific notation, and then we're going to talk about rational. And anytime we hear the word rational, we think fractions. Fraction exponents are really easy. X to the 1/2 equals the square root of x. There's like a little 2 in there. X to the 1/3 equals the cube root of x, and we'll go on from there. That's just a little foreshadowing. This is a great quote from, what is this? Office Space. That's what it is. If you could only use positive exponents, that would be great. So positive exponents, just remember, we always want our exponents to be positive. We don't want negative exponents. All right, so let's talk about index notation, exponent notation. The big number, we call that a base. The n, we call either an exponent or an index. Okay, and if you think about it this way, every single time, if n is a positive integer, then it tells us to multiply b by itself n times. Okay, so this is just b times b times b times b times ... b, and we just do this n times. So that's what you have to think about every time you do this. So for example, b to the n, I just did that one, is b times b times b ... times b n times. N being any number that we have. So if we have b cubed, it would be b times b times b. If we had b to the 7th, it would be b times b times b times b times b times b, 1, 2, 3, 4, 5, 6, 7. Sometimes when I get into really complex problems, all I have to do is rewrite it using the exponents, index notation, and all of a sudden it works out. 2 to the 3rd is 2 times 3 times 3. Just kidding. 2 to the 3rd is 2 times 2 times 2, okay, which comes out to be 8, obviously, but this is how we do it. Multiply 2 by itself 3 times. 3 to the 4th. Oh, and we have some common ones right this. Whenever we have a number to the 2, we say x squared. You can also say x to the 2, and that's okay. And then when we have something to the 3, we say x cubed. Those are just common words that we use all the time. If you hear squared, it means raise it to the 2. If you hear cubed, it means raise it to the 3. And then everything after that, we go to whatever number it is. So like this is 3 to the 4th. Right here, we could say 2 cubed. We could read that out as 2 cubed, and that's how it would come out. So 3 to the 4th is 3 times 3 times 3 times 3. And we go from there. Okay, anything at all raised to a 0 is always 1. Except for, of course, 0 to 0. This is a big debate. You guys can look it up and you can tell me what you think it is, what 0 to the 0 is. And that's up to you. You guys can tell me when we get to class. You look it up, see what they say. Some people say it's 0. Some people say it's 1. I don't know. What do you think it is? 10 to the 0 equals 1. Okay. 1,000,007 to the 0 also equals 1. Negative 5 to the 0 equals 1. X, Y, Z to the 3rd, B to the negative 74th, all raised to the 0, is also 1. Okay, so just know that anything raised to a 0 is 1. Just know that. Trust it, love it. The reason why we get that is when we get into divisions. If our division of exponents, when we have x2 over x2, this becomes x to the 2 minus 2. But if you also looked at it this way, a number, x squared, divided by the exact same number, that's going to be 1. But if we subtract the exponents, this gets us x to the 0, and that becomes 1. All right, so moving on. Negative bases, big mistake made here. Huge mistake. This is probably the biggest mistake people make when we do exponents. And I don't know how to express it any better. So this one right here, this example right here is negative 2 times 2. So the answer is going to be negative 4. This one right here is negative 2 times negative 2. So the answer is going to be positive 4. Big difference between these two. Big, huge difference. And so many people make this mistake all the time. Okay, so if it is inside the brackets, the negative squared will become a positive. If it's outside of the brackets, it just stays negative. All right, so consider the statements below. Negative 1 to the 1 means negative 1. Negative 1 squared means negative 1 times negative 1. So that's positive 1. Negative 1 to the third is negative 1 times negative 1 times negative 1, which gives us negative 1. And then negative 1 to the fourth is negative 1 times negative 1 times negative 1 times negative 1, which gives us positive 1. All right, so if we look at this, let's go into the 2's too. Negative 2 to the 1 is negative 2. Negative 2 squared is negative 2 times negative 2, which gives us positive 4. Negative 2 to the 3 gives us negative 2 times negative 2 times negative 2, which gives us negative 8. And negative 2 to the fourth gives us negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Okay? So look at this. When it's raised to an odd number, it comes out negative. Raised to the odd number, it comes out negative. Raised to the odd number, it comes out negative. Raised to the odd number, it comes out negative. But if it's raised to an even number, it's positive. Raised to an even number, it's positive. Even, it's positive. Even, it's positive. And the reason why is a negative times a negative is always positive. So if you have even negatives, they're always going to come out positive. Okay? A negative base raised to an odd power is always negative. A negative base raised to an even power is always positive. All right, so take your time on it, write it out. Start to stress to yourself to make sure you get these signs correct. Like, stress right now. Try really, really hard to understand what I'm saying on this one. Everybody goes, oh, yeah, I understand that. Oh, yeah, that makes sense. Oh, yeah, yeah. But then once I give an exam or an assessment, we miss this. And I think it's one of those easy things that you shouldn't miss, but we do. All right. Negative 3 to the third is negative 3 times negative 3 times negative 3. This gives us a negative 27. This is supposed to be negative 3 to the fourth. Sorry. So negative 3 to the fourth is negative 3 times negative 3 times negative 3 times negative 3, which gives us positive 81. Okay. If we have negative 3 to the third, this is just negative 3 times 3 times 3. So this is negative 27. Okay, now this next one, there you have a negative on the outside and you have a negative on the inside. So because this is negative 3 times negative 3 times negative 3 times negative 3, this gets us 81, positive 81. But that negative is still here. This negative is still there. So our answer is negative 81. Okay. This next one is negative 3 times negative 3 times negative 3 times negative 3 times negative 3. I'd punch that in the calculator and I get negative 243. But now because this is negative times negative, this becomes positive and we get 243. All right, those of you who like to do the work in your head, this is where you make so many mistakes on these negatives. So please, please, please push your brain to understand this negative thing and understand That negative signs are so important. All right, so our calculator, we do have an exponent on here. The exponent is right here. Sorry, right there. We call this a caret. Okay, so as I'm putting these in, you need to make sure you guys do this. So we have two different ways to do 5 squared. You can do 5 to the 2. Okay, so we press the button 5, then we press the button caret, and then we press 2, and then enter. Okay, or there's also a squared button on the other side, right here. So all you have to do is push that button, and that will just do 5, and then press this x squared button, which is on the left-hand side, and then press enter. And that just gets you, it just does another way to do the exact same thing. So 5 squared gets us like that. All right, so use your calculator to do the following. 5 to the third, 5 raised to the third. We just use our caret and then press enter. We get 125. Okay, now notice this is negative 3 to the 8th. This is the negative is on the outside. So we press negative 3 raised to the 8th. Okay, if there were brackets, this would be positive. But because there's no brackets, this is just saying the negative of 3 to the 8th. So negative 3 to the 8th gets us negative 6,561. Okay, if you're going to be using your calculator, make sure you punch in these negative signs in the correct spot. This one right here is negative 11 to the 4th. I would like to see you go, oh, I know that answer is going to be positive, and just go 11 to the 4th. I know that my answer is going to be positive because it's raised to an even number. But let's say you forget that rule. You just put in a bracket and go negative 11 raised to the 4th. And you get positive 1461. If you forget the brackets and you type it in negative 11 to the 4th, you're going to get negative 1,461. Or sorry, 14,641. And on an assessment, I'm going to have to mark that wrong. That means you have no idea what negatives mean. You need to be really, really careful on that and not just punch in the calculator and write down whatever it says. All right, so here's your on your owns. See how you guys do. I think you guys will do okay. Math is life.